Hi, I'm Mike Stanczyk and this is Digital Electronics Classroom. In this video, we will be looking at 2's complement subtraction. So if you don't know what 2's complement is, I recommend that you look at some of the previous videos so that you can learn about 2's complement and how we find a 2's complement value and how it represents the sign and the value, the magnitude of the number that it's representing. So. Alright, so we're going to get right into it, so let's go to the computer. Alright, so we're looking at subtraction, binary subtraction, with 2's complement. Before we get deep into that, I want to talk about how a way of understanding how 2's complement works. And so I want to look at the idea of rollover. Now I'm going to use decimal numbers for this because I think it's just easier to understand. So if we have one digit in decimal and I keep on increasing the value of that digit, right? At some point in time, we run out of the increasing characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if we increase again from 9, we would go to 10. But that 1 kind of gets thrown into the second digit, which we don't have. So what happens to the first digit? If we go to 10, then 9 becomes 0 again, and then it starts to increase back up to 9. So this is what we call rollover. So the first digit rolls over back to 0. Well, if you only have that one digit, then this is rolling over to 0 and counting back up. So we're going through that same set of numbers, 0 through 9, again and again and again. And so this is what a fixed length number does for you to experience its rollover. So a fixed length number experiences rollover. And so that means that, if we're counting up 0 to 1 and then we get to 9, the next number we're going to get is 0. And if we're counting down, we're going 9 to 8, and then we get to 0, then the next number is going to be 9. So this is counting up and this is counting down. We get that rollover going on. So it just cycles through those same sets of numbers. So we can use this fact to do subtraction by adding. And we do that with 2's complement. So let's take a look at how this works. So say I started with the number 6, and I wanted to subtract 2, minus 2. That would take me to 4, right? So we go from 6 to 4. Let me try something here. I'm going to do something a little bit different. See if I can. No, come on. Let me change. No, I guess it's not gonna. Oh yeah, just like that probably. Aha. Okay, so let's go ahead and do a red. Ooh. Okay, so if we start at 6 and we go to 4, awesome. And so that means we have a change of minus 2. 6 to 4 is minus 2. But here's the thing. We're looking at the start point and the end point. We started at 6 and we ended at 4. Now with rollover, there's another way in which we can do this. We can start at 6 and go to 4 by rolling over and then counting back up to 4. So how many positive moves did we have to make? We had to make 1, 2, 3 to 9, 4 to 0, 5, 6, 7, 8. So this is essentially adding 8. So we can add 8 to 6 and get 14, but the 1 gets thrown out, and so we're left with 4. We get to 4 by doing that. Or we can take away 2 from 6 to get to 4. And so with rollover, it doesn't matter which way we get there, we still end up at 4. And so we can subtract 2 by adding 8 here, okay? And what 2's complement does for us, 2's complement, it Oh, this is nice. It has a document colors right there. I didn't know that. This is cool. I'm excited. I'm learning some new stuff. All right, so 2's complement changes the -2 to a +8. So we can use then that +8 to affect the same outcome as adding a -2. Now, this is not actually 2's complement for a decimal. It's actually called 10's complement because it's base 10. Just like for binary, it's base 2, we have 2's complement. But that's essentially what we're doing. So we're trying to, instead of going downwards to that 4, we're going to go up and around to that 4. So we're going to change it into this number here to get there. Okay, so hopefully that makes sense. So let's go ahead and do an example. And I'm going to start by making a table, again, n and 2 to the n. So 0, 1, 2, 3, 4, 5, 6, 7. We got 1, 2, 4, 8, 16, 32, 64, 128. Great. And I want to do this decimal expression or equation. 50 minus 20 is equal to 30. Okay, so how are we going to do this in binary? Well, I also want to constrain ourselves to 8-bit binary numbers. So remember, we have to have fixed lengths. And so we're going to use 8-bit binary numbers. So first off, 50. So we've done this in our previous video. So if you were there, 32, 16, and 2 gives us 50, and so we have the number 0011, 0010. So that's 50. Okay, so there you go, 50. And then we have to get -20, but I'm going to start with +20. So +20 needs a 16 and a 4. So this is 0001, 0100. And then we're going to have 30 at the end. So 30 requires a 16, an 8, a 4, and a 2. So we have a 16, an 8, a 4, and a 2. So those are our three numbers here. Problem is that there's a subtraction here. This should be a -20. So this is 20, we got to make it into a -20. How do we do that? We do that with the 2's complement. And so 2's complement starts with the 1's complement. So we got flip the bits, and then we add 1 to get our 2's. And so we add 1. And so we have 1 plus 1 is 2. Carry the 1 up here. This is going to be a 4. Carry the 1. And so on. So we get that. So we got 1110, 1100. Now this represents the number -20. Where this one represents the number +20. So we took +20 and got to -20 by doing 2's complement. So let's go ahead and do the operation now. So I got 50 minus 20 should be giving me a 30. So we're going to take 50, 0011, 0010, and we're going to subtract 20 from it. And so we're going to add this number, which is -20. And we do that, we get 0, 0, 0, 1, 0 is 1, 0, 1 is 1, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0, carry the 1, 1, 1 is 0, carry the 1, 1, 1 is 0, carry the 1. Now here's the thing, right? We only have the 8 digits here, so this carry out is disregarded. So we don't care about that, it's gone. And so we're left with this number right here, which is 0001, 1110. That should represent -30. And if you check with our, +30. And if we check with our original calculation, we can see that's the same number, so they match. There we have it. So there's an example of using 2's complement to change a number 20 into its negative number, minus 20. So the 2's complement signed representation of negative 20. Then we added that negative 20 to 50 instead of trying to subtract a positive 20 from 50. And so our only operation we did here, our operations are a 2's complement operation, which incorporated flipping bits and adding 1. And then we added that number to 50 to get our answer. So notice that we did not do any subtraction to affect a subtraction operation, which is what we're looking for here, because doing an addition and having only addition is really an advantage when we're talking about computer operations. Let's do another example. So in this example here, we're going to just flip it a bit. We're going to do 20 minus 50 is equal to minus 30. So let's find out 20, 50, and 30 first, what their values are. We already have these. And so this is 0, 0, 0, 1, 0, 1, 0, 0. That's 20. 50 is 0, 0, 1, 1, 0, 0, 1, 0. And 30 is 0, 0, 0, 1, 1, 1, 1, 0. Okay. So now I have two negative numbers. I have the negative here for 30, and I have the negative number minus 50. And so we have to do a 2's complement twice. So we'll do a 2's complement here, flip the bits, 1, 1, 0, 0, 1, 1, 0, 1, add 1, which gives us, so 1 and 1 is a 0, carry the 1, that's a 1, 1, 1, 0, 0, 1, 1. So this number represents minus 50. And now we'll do it over here. So 1, 1, 1, 0, 0, 0, 0, 1, add 1. And we get 0, 1, 0, 0, 0, 1, 1, 1. And this number here represents minus 30. So performing the operation, I'll just do it up here. So this is 20, 0, 0, 0, 1, 0, 1, 0, 0. Minus 50 is adding this number, adding a minus 50, 1, 1, 1, 0. Adding those together now, so plus. So this is 20 plus a minus 50, and we should get a minus 30, right? So 0, 0, 0, 0, 1 is 1, 1, 1 is 0, carry the 1, 1, 1 is 0, carry the 1, 1, 1 is 0, carry the 1, that's a 1, a 1, and a 1. This is our final answer. Is it equal to 130? Or sorry, is it equal to negative 30? And I compare these two, and I can see they are exactly the same, so we have a match. So that's how we do it. So there's 2's complement, using 2's complement to do subtraction with binary numbers of fixed length. Thank you so much for watching. Hope you found value. See you next time. I'm Mike Stanzik. This is Digital Electronics Classroom.